you for having me. I don't know if you know me. My name is Alessandro, and I'm a technical evangelist at Microsoft for 6 months now. So I'm pretty fresh in Microsoft. If you have any question about how does it feel to work at Microsoft, you can reach out to me. So I have an open source background. I used to work for Red Hat and a bunch of other companies. I've always been around open source. So people ask me, why you join Microsoft? Well, Microsoft is doing open source, so it's not me changing, it's them. And I think now me as well. So that's my Twitter handle. Feel free to tweet. But it's a funny story about my Twitter handle. I have the same. There's a dictator in Africa, in Congo. It's called Bongo, and they always confuse me for the dictator. And I have nothing to do with him. So Bongo, Ali, whatever. It's a bad guy. So I'm not the bad guy. I'm the nice guy, which came here today to tell you something about continuous integration, continuous delivery, which is the topic of this meetup. But I always wonder, continuous delivery of what, right? What do you deliver continuously? Because if you deliver the wrong stuff continuously, you're just making continuously wrong decisions, or you're not really making any people on the earth happy or happier than it was before. And that's the whole point here, right? So we want to make people happy. That's what Microsoft does. Well, not happy ending or anything like that. Microsoft is a tooling company, right? We historically built tools for other people to build more stuff. And that didn't change, and we used to be fully closed source, so we used to hate open source, and instead now we just do it with open source. It's just a different way of doing the same thing. So we provide tools for you to do interesting things. So one of the tools, or one of the interesting things you can do with our tools is DevOps, right? To integrate development and operation into one single idea of delivering value continuously to your customer. So today is not going to be like a million PowerPoint slides, because I don't like it, and I like to show you actually what is happening from the perspective of a developer. I don't call myself a developer, but I can fake it sometimes. So I'll show you what a developer sees when is actually in this loop of feedback and continuously improving on the code. So we're gonna continuously build, integrate, test, and deploy a multi-container application. So I guess from the previous talk, I assume everybody knows what a Docker container is. I'm not gonna talk about it. So that's what we're gonna use, and this is where you can find everything explained. It's on GitHub. We have, of course, GitHub. Microsoft is the first contributor to GitHub repository. Did you know that? It's a funny thing. So we're going to use Visual Studio Team Services, which is our, let's say, the brain of or the center of our offering. So if you are familiar with TFS, it's a product been around for a while. Team Foundation servers or services. So this is the cloud version. You don't need to install anything. As a matter of fact, this is also a question that I get all the time. Why do you have a Mac? You work for Microsoft. I have a Mac because my team, my role is my team is Developer Experience, it's called. I'm a technical evangelist in the Developer Experience team. So I help developers to reach their potential, which sounds like worse than it is. I just show them how can they use the tools so they can do something cool, right? So so most developers, and I think also in this room, most developers have a Mac. So I want to show that you can do this with a Mac or a Linux machine, from your phone even. You don't need to be a Windows shop, or don't even need to code in .NET. So this one tool that I'm going to show, I'm going to use a lot. The second is Docker Swarm. It's just Docker, runs with the same command line tool, so it is Docker. It's just that it's Docker on steroids. It's Docker on on a cluster of machines, because we are talking production here. You don't want to run all your stuff in one node, so you want to have a cluster of nodes that run your container. So, and where do you run this stuff? There's a there's a cloud called Azure. We make that, and we have a thing called Azure Container Service, which is basically a way for you to deploy a Docker Swarm cluster in a matter of minutes. So there's always the problem with these container orchestration frameworks, either Kubernetes, Mesos, OpenShift, Swarm. Swarm actually makes it a little easier, but they're all very complicated things, right? We're talking about distributed applications here. Nothing simple about those. You have to maintain states between masters. It's complicated. So what we do is like we make it easy for you to deploy. So we have either the portal is a point-and-click interface, or you have an MD command line. We have everything is on GitHub. I can show you later. It's also in the same github.com/azure/SES engine. It's where we distill the best practices of running this container orchestration at scale. We distill all the best practices into, well, basically JSON templates that describe how to run this stuff, and then you just push these templates to Azure and magically you have a Docker Swarm. So in our case, because time is limited, the Swarm is already there. I'll show you how to connect, but you will see that it's there. Even if it wasn't there, it would take 5 to 7 minutes for a small cluster that I'm gonna use for me. So it's like one master and 2 or 3 nodes, nothing fancy. So container registry is just our way of giving a registry to our customers. So you don't need to push and pull things out or in and out of the Docker app. You trust it or not, I don't know, but this you definitely can trust, because this container registry lives within your subscription, so within your, let's say, virtual private data center in Azure, and is protected by credentials that you only, they also can hook to the Active Directory that you're already using to access Azure. So, and then Bash, well, why not? So Visual Studio Team Service is our hub where you can integrate things into and out from. You can call Concur CI if you want. Visual Studio Team Services as a simple interface is basically you can start from simple things like it is a Git repository, of course, but you can use GitHub as a Kanban board, Scrum process, Agile process built in. But you can use something else if you so like. And the core of the service is the build and release pipeline. That's what I'm going to show you, and that's what I'm going to spend most of the time on. It's crucial to the functioning of Visual Studio Team Service. So it's kind of an aggregator of teams and projects around builds and release pipelines. Pretty much like Concur is a way of describing how to build a product, how to build an application, and how to deploy in its final state or form into whatever you like. I'll show you the options that you have. Container service, as I said, it's a way for us to provide the first part, right? This is the most annoying, but also where people get most excited. And me myself, being a former sysadmin, I love this stuff, right? I mean, it's where it's fun, but it's in the way between you and the value that you want to deliver to your customer, right? So this should stay out of the way. You should focus on the application. So we make it easy to get there, and then it's up to you to bring your application. You can bring it in a continuous fashion by using the right tools, which, by the way, we also provide. So, and this supports the major container orchestration frameworks at the moment. We welcome pull requests and new code. Just JSON. If you can write JSON, it's not that difficult after all. But it's we miss Kubernetes out of this. Of course, we have this US and Swarm, and Kubernetes pretty big. And we're going to include also, well, we just announced that we bought Days. Do you know what Days is? It's a PaaS layer built on top of Kubernetes. So it doesn't mean that we are more serious about Kubernetes than Swarm. Our partnership with Docker is pretty strong, and it's even stronger. When is DockerCon this week? Next week? We're going to announce a few interesting things there. So today I'm just going to show Swarm, just because it's simple and easy to understand. You can, of course, have it supported there. So Docker Swarm, as I said, it's just an orchestration framework for containers. So imagine you have a container, and in our case we have an application made of multiple containers, 4 if I remember correctly, that just run in this cluster. So quite simple to understand. You have a master node. You have a master node and a bunch of agents, right? The agents are in a thing called virtual. Right. Well, so agents of Swarm, they live in something called virtual machine scale set. So you can scale agents. We start with 2 today, but I can scale to up to hundreds of agents if my application scales. And there's a load balancer in front that, in fact, we have more ports, and you can dynamically map ports to your application. You can do it with Docker, you can do it with Kubernetes, and the master is just where you send commands to deploy your application, right? So, 12 minutes. So let's move on. Container registry. I'm not going to say anything about it anymore. And that's what we're going to do, really. So this is the most important slide, and probably the last one before the demo. So we're just going to deal with code. And then I'm going to show you, of course, what's happening. But imagine you are a developer, and the build and release pipeline are set. You don't really care or know what's going on in there until you break stuff. But if you don't break things, then this process is completely transparent to you, and that's how it should be. You get this, so you push code to GitHub, and then this triggers build and pipeline actions or triggers this thing in Visual Studio Code, Visual Studio Team Services. So you build the images, you push them to container registry, and then the release takes these artifacts. In our case, the artifact is the Docker Compose file, which is just describing what's going on, and use that plus the images to deploy it to the Swarm cluster, and then you have the application. So, without further ado, and if you have questions, just interrupt me. Yes.
Yeah, I had a question about number 3 on your
right.
Is the arrow from the build to back to GitHub? What does it do?
So, it's a good point. Why did
tagging of the build maybe?
No, the tagging is done on the registry. So you build the tag and then push. So what is the feedback to GitHub? That's interesting.
Does it provide the feedback of the status of the build?
Yeah, of course. You can also, like Travis CI or Werker, you have this little JavaScript thing that you can embed in your GitHub repository that says when it's successfully built or not. We do also have a dashboard within VSTS, so it's a feedback on the build status. Good point. I never actually use it, but it is there.
And the registry only has arrows going into it.
Only as
it's comparable to the Docker Hub. So
yeah,
you
true.
also have an outgoing thing.
Yeah, no, that's supposed to be the other way around. Sorry, mistake. Yeah, so the registry is push and pull,
yeah.
But the Swarm really doesn't push to the registry unless you want to. That's not the case in our case. So we're just gonna push to the registry, and the swarm itself we're gonna pull from the registry using the credentials from the release pipeline. So it's nothing out of the ordinary. So let's talk about demo. So I'm gonna go through the how did I build this, right? So let's concourse. So let's you can see the screen. So that's how Visual Studio Team Services welcomes me. So these are my team, my pull requests, my work items. My work items are the cars that have been assigned to across all projects. So it's kind of imagine I'm a developer. It's a startup. We have dozens of projects, but every project inside the project there can be multiple Git repository. So you can either store the code in here. So this is one Git repository, but you can have multiple, and you can use these repositories. You can easily add a repository like this, and then you can store it in Git or TFVC, which is the old version control of Team Foundation. So, and then you can combine this repository in your builds if you like so. So it's interesting. So you have, of course, like a access control to your code. You keep it to the minimum, of course. So we start at the dashboard, right? So the dashboard is something that you can customize yourself. You can add anything you like, and this is all extensible with extensions, of course. So you can see deployment status right here. Then you can define which build definition I want to show and which release definition I want to show. So I'm showing this. So I have a bunch of builds that are completed and a bunch that fail. So I can build a dashboard and also the cars, the user stories that I'm assigned to. So I can build a dashboard that shows me at a glance the status of my builds, and there are more that you can add, like just build history. It's all very. Can also export this to. So I failed until I got it right. That's what DevOps do, right? So you can have your own metrics. You can pull metrics out of Azure. You can pull metrics. You can embed graphs from Grafana. You name it. Then this is the dashboard. That's pretty self-explanatory. The code, but my code lives in GitHub, so nothing fancy to see there. This is interesting. So I noticed there are a lot of Z on my own page, and I want to remove that because I don't like Zs, whatever. So what I can do here is to reassign it to somebody else, somebody in my team at Microsoft. I can branch. Well, if this was a repository within Visual Studio Team Service, I could branch it directly, but now I have to go to GitHub to do it. But it's a card, right? So I can take it and I can move it to active because I'm starting to work on it. So we were discussing Jira, Trello before. Imagine this, but integrated in your app of development, right? So it's pretty cool. I love it. This is something I was looking for. And see, we have kind of a opinionated process. So we say we think Agile, CMI, and Scrum is the three most used processes that you can think of, but you can always, you call it Kanban, whatever, and you can change which project use Kanban, right? I don't want to mess up with somebody else's thing. So, but the thing is, you can customize your work items that matters to you, whatever those are, epics, task, test case, bugs. There is bug in there, yeah, it's bug, but maybe there is no. Well, it is pretty comprehensive, but you can also change. You can add backlogs levels, so then you can group all the bugs into their own. For example, so let's say bugs with Z. Then choose the color, and then bugs work. So and then you can. It's not, of course, like we know that this is not the most fully featured product out there. Maybe some people don't need all these features, but I think we are doing a pretty good job, and also we listen a lot, and we try to improve on this quite often. And we use this ourselves at Microsoft to build our own products. So we eat our own dog food. But let's go back to whatever we are trying to build. So let's talk about the build definition. Let's look at the code first, right? So the code is on GitHub. You can fork it, and it looks like this. It's very simple stuff. Most of the code is in here. So these are the 4 containers, and that. Right. So these are how we build. Some stuff is written in Python, but some stuff is also written in Java. Am I correct? Yeah, this is Java. So, and these are the Docker files that are going to be used for building things. So this one is Maven, so Java, and this one is, you start from so also Java, but this is a component made of Python, probably Angular, if I'm not correct. But anyway, so containers, and I want to orchestrate the deployment of this, so, and the build of this. So what you do, you add this. So indeed, this is not as powerful as Concourse, I admit that. It's also, this is a bit still a bit too visual for my taste. So you can export this in an XML file. You can export this definition in XML file and re-import it in another project. But still, you can just edit the source code of this. It's not good as Concourse CI, but still, it's something that many you can find useful in itself. So this is how you edit. These are what's going to happen, right? So a bunch of tasks that build and then tag and then push my image to the Docker registry. And the Docker registry is just a variable that you define in here. Simple as that. So it will be replaced at build time. This variable will be replaced at build time. And there are a bunch of predefined variables like the build number and things like that. So, and how this is triggered? It's triggered by continuous integration, which means every time I commit change to master, then and I can choose which branch will trigger the CI. So I can have this definition, and then I can clone it. I can clone it, and then instead of master, I can point it to development branch or whatever other branch I wish. So that's one thing. That's the definition of my builds, right? So, and then immediately after that, immediately after a successful build, I have a release step. A release called microservice shop release, this one, which I can edit to show what happens during the release phase. So the build builds the product, builds the Docker images, push them, and then creates an artifact. I missed that. It's at the bottom. If it's not clear, just let me know. So these two, they simply replace build number in the Docker Compose template and the registry URL. So it literally you set to change this placeholder with the variable, and then well, I move the Docker Compose to template to Docker Compose, and then I publish an artifact, which is the what I'm really gonna use to deploy. So the images goes to the registry, and the only thing I really need to deploy is the Docker Compose file, which is then handed over to the release, and the release is gonna use it to do two things. So one thing is to copy the file, the artifact to the master, and then run this command, which is nothing fancy again. It just logs in the Docker registry, and then deploys the application. So if the application is already running, we're just gonna pull the new builds because they are tagged with the build number, and then run it on. It's gonna bring down one and bring up another one of the same, but with different build numbers, with different tags. You can get fancy there. Docker Swarm includes like rollbacks and running upgrades and all kind of things, but it's all in the Docker Compose file, so it's not really relevant. And last but not least, so since they are running on different agents, this is also quite new. So agents are not, we can actually run the agent in a Docker container, why not? Or you can install it on a machine. We have, of course, Windows and Linux agents. So the tricky part is that this runs directly on the master as an agent, and this runs on an agent that we provide to every customer, every user. By the way, this is free up to 5 users. So if you want to use it, it's actually free until you reach the 6th user. That's it. That's all you need to pay to us. And after that is like probably like 12 euros a user a month, something ridiculous. But so we don't make money out of this, but we use this to trigger more things that make money. That's all I have to say about selling. And then one more step is to perform a performance test, right? So I said let's continuously integrate, deploy, and test. And this is our test. So I arguably the simplest test you can think of. Just getting a 200 out of our website. And the second one is performing a quick performance test on the website. So, and it's going to store the result for every release. You can compare results. So you can see if somebody introduces a regression that will slow down your website considerably. So let's now that we see what is going on, or what supposedly will go on. Let's see. So this is the website I'm talking about, and it doesn't work because the application is slightly broken. At least the front end works, but inside some components is broken. But let's say that I see that, oh, there are too many Z. In fact, somebody did create a card for me, so a bug, so to say, to remove all the Z from the website. Okay, sounds something I can do, even me can do, and I'm not a coder, so that's the extent of my whatever Python. So this is Visual Studio Code. If you know it, who doesn't know it, it's a cross-platform editor made by Microsoft based on some open source technology like JavaScript. It's pretty powerful, and since I found it, I stopped using Sublime. So you know, but it is free, so you don't need to pay us a dime about this. But it's pretty cool editor. So I found the bug. I think I found it. I think there are too many Z over here. There's one over here, and there's one over here, right? So imagine this is a stupid change, but can be a feature, right? Or can be an important change to your code that you want to see the effect right away, right? So I save the file, and then it's going to tell me here that I have a pending git change. So fix the Z's. What was it? Number 1, I think, the issue. So cool. Now I'm gonna push to GitHub. So this is what I see. Well, that's not the way, but this is what you see, and then we have builds. So if you look carefully, there's a build running. So it's been triggered by GitHub. Let's see how is it progressing. Oh, it's building, and because it's almost the same code, it goes quite fast. It did publish the artifacts, right? Now let's see the release. So you have a release in progress. So it did already. The application is live because it's so small change that it was really almost instantaneous. It's running on the hosted agent now. So the first one is on our own on my hosted agent because it's hosted on the master. So you can build checks in here. So you can deploy to a test environment and stop before progressing to the next step. You can have approvers, you can have you can deploy to a test site, have manual testing and then trigger the next step automatically. The smoke test should go fine. So Windows based, and then it's going to take a minute to deploy to do the quick performance test. In the meantime, this is being deployed, and the Z are gone, right? So I just show you the release because we wanted to follow it, but not if normal condition, this you should not even care or see. And in fact, you can follow. Oh, by the way, you have Visual Studio is pretty cool because you can see you have also you have a bunch of things here. You can also have an integrated terminal that can tell you get status and do fancy stuff, fancy things like npm install, whatever. But you can tell also here there is a connection between VSTS and Visual Studio is down there, but is there. Everything looking good. If this was failing the builds, it would have told me right here. I click here, it sends me to Visual Studio Team Services. Actually, this is not where I'm supposed to click. I'm supposed to. Here, right. So I can see what's going on in my builds. Well, there's a connection between the two, so don't worry about it. The idea is we don't need to get out of the code editor to push code and to integrate my code into whoever else in my team. So then I can go to work and say, okay, yeah, I did what I was supposed to. Then I solve this and I open it for QA, for example. So I can adapt my process to my way of working. So that's an interesting proposition, I think. So this is that's our proposition. So why Microsoft is so interested in DevOps. And I've been doing DevOps for a while now. And I always find it very fascinating. And because Microsoft builds tools, which is 1/4, 25% of DevOps, so to say, comes cultural automation, what else comes? Cultural automation, measurement, and shading. So we build the tools to get a proper DevOps culture in place. So the tool isn't only supporting the whole thing, but and it's not only that, but we do give, we think, good enough tools, and we are constantly improving them all the time. So, any questions about what I just showed? Maybe you want to see the Docker swarm itself. You can tell. If you SSH initially can do Docker service ls, and you can see the three services. There are actually more PS. Then you can see the for example this there is only one running, and the other two are shut down because they are the previous version. So and then Docker Swarm regularly cleans up what it needs to be done. So now, well, you can tell. Well, anyway, so what we are now is that I can make another change to my code, and then bam, it's going to be pushed down to the production. So where are we? So I'm sure you're all like this now. It's just late, and the food was good. So let me just add one thing. So we have an important event in 24th of May. So a month and a half from now, Scott Guthrie, which is a big shot in Microsoft, it's a crazy guy. It's gonna be a one-man show. It's gonna code from beginning to the end. It's going to be 700, 800 developers at the event, so if you don't want to miss it, register. It's free, so it's going to be a whole day of coding and cool, geeky stuff from Microsoft. So reach out to me if you want to discuss anything about this, and I'm always curious to know to improve my demos and if things are relevant to you. So please cannot reach me at Twitter. It's Bob. It's not the bad guy, the good guy. So thank you. Sure.
You beginning of the demo, you said you can clone a build step.
Yes.
Like that?
You can clone entire builds.
And change, for instance, if you want to build from a branch. So suppose someone wants a branch, can you also do this automatically when you find out that there's a branch created?
Sorry?
Suppose you GitHub, you add a new branch, push it to GitHub. Does it do the cloning? Can it do the cloning automatically?
You want to create a build automatically?
Yeah. Based on a new branch, for instance.
Oh, okay.
Like each feature branch should have this build plan.
Interesting. I guess you can. So everything you see, I understand. So builds are you can import and export them as XML, so you can still add them in place. But everything you see is all API driven. So you can trigger a build via an API, CUR, SDK, whatever. So you can also create a new build out of an API, right? So you can clone via the API. So you can think, and I can think, and I can probably help you come up with something, that a webhook out of GitHub can fire off API call that clones a build and change one parameter, the branch from which it is triggered. So it is doable. It's an interesting proposition actually. We can and the best part is, okay, if it doesn't exist, you can build it. So that's the idea of extensions. So for example, even out of the box, I'm not even able to build a Docker container in VSTS because everything, by design, we put everything into extensions. So Kubernetes, smoke test, all the smoke test task wasn't even there before I installed the extension. So let's say that I have this crazy idea that I want to build, I want to clone a build after a branch out on GitHub. I should be able to create an extension that does that. For example, the one that I've been involved in development, that's Kubernetes. And it's really, what is it? Where's GitHub? So this is Node.js. It's not rocket science. Tasks. So apply. You can build something in Node.js that does exactly what you like. So I don't know how to start, so even start what you ask, but probably with a little development we can come up with something. And these all are, so it's a marketplace. You build it in GitHub or even privately, you package it and you put it in the marketplace, and usually gets accepted quite easily. So it's open for everybody.
One other question. Can you show us what's beneath the test tab?
Right. Yes. So it should have been done by now.
Because I'm interested in to see how you can integrate complete testing.
Yeah. So let's say.
It's probably an extension.
Yeah, but a built-in extension. So unit tests, you probably want to put them in the build phase, but you are free to put them anywhere you like, really. So, sorry, I didn't show you the task catalog. So you have tests that you can run. So you can integrate with what's the name? Well, all the Java stuff that does testing, but also we gear this quite ably towards mobile development. So you can definitely do whatever you like. So you can, for example, deploy Azure stuff from this. But there is also an AWS extension. It's an API, so it's not rocket science. So somebody triggers AWS out of this because that's what they like to do. So of course these are the easiest thing you can do because we build this. So of course we build the Azure stuff in there. But you can run anything you want. And the testing part is also part of our testing suite called Xamarin Test Cloud, where you can build application for mobile once, then you send it to Xamarin Test Cloud, and you can run tests on devices automatically. And if it doesn't fit in this scenario, you can run JMeter load test or other kind of test. So there's a whole section of the marketplace where you can get this extension. I think it's so you have a bunch of test manager, of course, but also something popular.
Okay, I see. Thanks.
See what I mean? I mean, it's not too. It's part of the app. This is what I talked about examining text cloud, where you can get the results out of it and put them in. So about the testing that we just performed, there's a load test. Results are stored here, and I didn't set anything like. You can also set a threshold, say if it's more than 200 milliseconds, fail the release. So roll back, don't release. If you put the test before the actual release, and if you have done that, you can stop before deploying to production. If it's too slow, if the test is too slow. So.
Another question: how's the community behind behind developing the extensions?
Oh, pretty big. It's there are lots of I don't know how many. Let's say doesn't count, but you can build your own. There's a link, and it tells you everything that you need to build your own. So you have a REST API. There's authentication, of course, but and then you can build on top to build your extension. And it's really not, it's just a bunch of, it's a manifest file, of course, that describes what it does, and then HTML, JavaScript, and you can actually use other languages. I think Node is pretty popular to build extensions, but I guess you can do it with almost anything you want, also .NET. Cool stuff, if you think. Well. But everything is cool. I mean, nowadays, concourse is cool. I mean, Docker is cool. Everything is cool. Just that you have to use what you really need.
Okay.
Thank you.